Will Kurt is currently the lead data scientist for the pricing and recommendations team at Hopper. His talk would show how our current environment of global pandemic, political unrest, and economic uncertainty forces us to face the limits of probability as a tool for reasoning and understanding. We're very excited for this talk, which touches upon some very interesting current problems from a theoretical point of view, but also a practical one. So welcome, Will, and you can start sharing wherever you are ready.
Awesome, thank you so much. Let me see if I can share my screen. Okay. All right. Okay, just real check. Can everyone see my screen or anyone see my screen?
Yes.
Great. Okay, so that was a great introduction. Thank you so much. And thank you for having me at this conference. I'm really excited to do this talk today. So yeah, I've been thinking a lot during the recent months sort of about probability, as I always do, but also sort of the limits of what probability allows us to think about and express and understand in the world. And so this talk is about both what probability does really well and sort of what the limits of probability are and how we have to, as whether we're data scientists or technologists or however we frame ourselves, sort of think about other ways to understand the world in order to really address problems that we see and understand things. So starting out, let's talk about probability and how it works. I know we have sort of a range of different people here, so I wanted to give an insight into why probability is useful in the first place. So as mentioned, I lead a pricing and recommendations team at a company called Hopper. We do air travel. And so it's a very interesting time to be in a pandemic. So one of our core products is called Price Freeze. And if you are looking to buy a flight and you see a ticket that price is good, but you aren't ready to book yet, you can freeze the price in for a certain amount of deposit. And then you can buy that at that price, right? So if it's this $1,000 trip to Paris, you can freeze it for $25, and then that price will be locked in. If it goes up, we have you covered. So very interesting product during a pandemic, and we'll sort of see how that played out in a minute. But first, sort of how do we think about this problem probabilistically? How does this become a data problem? And we can see here, right, this $25 price freeze, we can think of this as a row of data. And we have this dollar amount and the probability it will attach, right? This is a binary sort of yes or no, did this product actually attach? Let me get a little pointer too. So this is just really simple data that we have. And when we look at this data, we have this sort of noisy world, right, of different things. Let me actually just minimize this for a bit. We have this sort of world of data that we can see, and it's sort of noisy, right? We sort of see something here. If you look, you see there's some sort of pattern here, and there's a lot of variation, but we want to kind of understand this data so we can make decisions. Because what we want to do is we want to come up with like, what's the best way to price this product, right? And so we see there's this relationship where as the price goes up, the probability that you'll attach this product, that you'll freeze, goes down. That's intuitive, that's what we expect. But then what should we actually charge for this, right? And we need to think about that. So we think about that using the tools of probability, right? So this is sort of a model we'll come across many times in this talk, this sort of big eyeball, this brain, and this world, right? So we observe the world, and we come from sort of a hypothesis about that world, and then we come to some action that we want to do given that hypothesis. So this observation is that the clouds are dark, and our hypothesis is that dark clouds imply rain, and therefore we say we should wear an umbrella. Now, this is sort of the qualitative view of this. We want to put this to some numbers. And so what we do as probabilists, as data scientists, as statisticians, is we look at this data D, and this is going to always be an important variable we have here. And we say, okay, what's the data? What's the hypothesis? We try to give some number to this by saying, what's the probability of the hypothesis given the data? So this is sort of the heart of probability, and we want to sort of learn this through different ways, but we basically want to come up with this, and this is this number in the end, right? So we say, given that I see dark clouds, my hypothesis that it will rain is 95%, and it makes sense to say if it's a 95% chance of rain, we should bring an umbrella if we go out. Now, of course, in practice, this gets a lot more complicated, and I don't want you to be overwhelmed by this. This is actually just logistic regression. But what we have here is the core of this is that we're going to learn a model that learns the hypothesis that you will attach a flight, right? This is a binary yes or no. Will you purchase price freeze? given the data, which is some price. So we have a bunch of historic data, and we're going to figure out some way to learn a model that does this. We're going to actually learn this linear equation here. And the details of this actually don't matter. The important part here is that what we're really learning is this idea of just sort of this basic probabilistic thing. What do I believe about the world? Given the data that I have, right? This is over and over again what we kind of will be thinking about, my beliefs given what I've seen. And so what we come up with is a model of how the world behaves, right? We have this simplified version. We had a few slides ago, this data here, right? This is sort of very real, but very messy. It doesn't tell us what we think. We can't do much with it on its own. But once we have this model, right, we have this nice line that represents what we believe. We have this relationship between what we can charge for a price and how likely we are to think it's to attach. And so this model forms the foundation for what we think the world is. And this is an important part of the logic, right? We're imagining the world as this simplified line, this model that we've learned. And this is all just basic probability. And the magic part of this is we can say, okay, let's multiply. This is just taking this previous line here, this blue line. If we multiply that by the price, then what we get is this line that represents how much money we would expect to get from each person at this price. And this is a simpler model than what we would use at Hopper, but this is basically the idea of how we do this. We take information and we condition it on the probability that someone will purchase this product. Now, actually, we have a model for saying what the best price would be. And so this is interesting. And the intuition here, if you're not quite getting it, is that so more people will attach at a lower price, but you get less money from those people. So that there's a sweet spot in here where you're getting the most money from the right proportion of people. And so you can see in a very, very practical, non-philosophical sense, probability is super, super useful because now we're able to say, if we charge this about $35, we will be getting the most value for our users. And this is useful because if you didn't have this, right, if you didn't have probability, you might say, well, let's charge $20. And then you'd be leaving 20, 30 cents on the table for every person that comes in. So it doesn't have to be this probability is good because it helps you understand the world, although I think it does. There's a very practical sort of business-oriented sense where probability is useful. Of course, one of the initial limits of probability we come across is this problem that this is our model we have of the world, but this model lives in our head, right? There's a thing we'll talk about soon, which is this confusion between the model and the world. But a big problem occurs in probability and in data science in general when the world changes. So as I'm sure everyone is aware, this is I'm in the United States, so some of my things will be a little focused in the US, but I try to keep it as global as possible. But in the US, this is what was happening around early March. We started having cases go up. And in this point in the pandemic, we are very clear what was going to happen next in the story. But at this point in time, it wasn't totally obvious where this was going, but this still creates a change, right? So we have this small bit of information, this small change in the world. And this is really fascinating. This is airline ticket prices, average prices that we see over time. And so you can see that that change in the world has an impact on how the world behaves. So the pandemic starts to come, airline prices drop down. That's not particularly surprising, but this has a huge impact on how Hopper works and how our model works. So this model we had, these attaches are slightly different than what you saw on the other slide, but what we see is this huge spike in attach, right? Now, on the one hand, you say, well, that's obvious. People are using this product more because prices are going down and they're excited about low prices. But the important thing here is our model doesn't predict this behavior, right? The model does not think this is happening. This is the same price. This is being charged the same price as it was yesterday, but we're attaching at triple the rate. So that's a very tricky problem for probability because when the world changes, our models become less useful. And as the world changes more rapidly, we become really limited in what we can do with these models. But I don't want to say that's the end of the usefulness of probability. So that when this happened, we had a really interesting meeting and our models aren't working, but we still have to make decisions. So this was a chart that I made on March 5th, and there was only about 200 cases of COVID-19 in the US. And again, in retrospect, this seems like almost comical, but this was at the time not so obvious. So I said, okay, here's things that can happen, right? If prices rise, so this product, again, freezes a price at a certain value. So we lose money as a company if the ticket price goes above that value. Since people were buying lots of tickets at a low price, the one concern would be actually if the world got better instantly, prices would resume and we would owe people a lot of money. And so we would lose a lot of money on this. if there was a global pandemic, which at the time was seen as sort of the insane situation. I thought this was realistic, but this was not an obvious thing. Our margins, the amount of money we'd expect to actually take home from all this would go up. We wouldn't have to worry. This actually ended up happening. And then there's sort of various business as usual cases. Now, the details of this aren't important. The thing is that quantitative reasoning and probabilistic reasoning, even in a very uncertain world, still are useful tools that help us to sort of understand how we can do our best, right? So given the fact that the models aren't working, the models don't really understand the world right now because they're trained on the past and the past doesn't look like the present, we are still able to use these tools. So probability, even in extreme situations, is a useful and valuable tool. And I don't want to take away from this talk to be, oh, I guess we shouldn't worry about probability. I think probability is fantastic. But I want to also talk about where probability doesn't cover everything we really need and the limitations of this as a tool for reasoning. So I want to talk about one of my favorite ideas in probability, and this came up a little bit before, and it's called the mind projection fallacy. So there's a famous probabilist called E.T. Jaynes, and he had this idea of what's called the mind projection fallacy. Now, a very, very important concept of probability is that when we say something has a 0.5 chance of happening, a 50% chance of happening, this is a statement about what we believe about the world. So again, the theme we have here is that there's this state of our mind and there's the state of the world. And initially you think, well, this isn't confusing, right? I know that, what's the fallacy here, right? I know that this is the state of my mind, not the world, but very quickly we kind of forget this. So this is a sample of Brownian motion. It's often called a stochastic process. It's a sum of random variables. And when we say things like stochastic process, or random variables, we sometimes imagine that this randomness is out there in the world. But in reality, what we mean when we say that is that the randomness is a statement of our mind. If a process is stochastic, it means I don't know everything about how it's going to behave in the future. The stock market is stochastic. It's driven by real things, right? There are tons of processes and transactions happening. We just can't know them all. So this process seems random to us, but it's important to remember that that randomness is a property of our minds and not of the world. And this is true even for things that are unknowable. For example, like Heisenberg's uncertainty principle, right? There's that classic quote from Einstein about God does not roll dice. And when we think about God does not roll dice, we think, yeah, the universe can't be random. But if you just switch that around and say we can't know about the state of the universe, absolutely, then that doesn't seem as shocking. And I always use this example. Nassim Taleb wrote this book called Fooled by Randomness. And we have this sense that, randomness is this wild force, this external thing. But if we rewrote this title, and this is a great book, I think it's a very good book. So this is not a critique of the book, but of our idea of randomness. If we rename this to, I'm fooled by the ignorance of the full nature of the processes which influence my life, it seems almost obvious, right? So for those who haven't read, this is a book about how things we don't understand influence our life and make our life go in directions we might not understand. So this is a really important idea. And like I said, when you clarify this, that it's really a statement of ignorance, it helps you understand a lot. And like I said, when we think way back to our models failing at Hopper to sort of correctly predict the price, the attach rate, that's because the model is a property of our mind. Now, you may think this doesn't come up that often in practice, but a great example of this is actually outliers, right? So when we have outliers in our data, we very much typically think of, let me see if I can move this a little bit out of the way. There we go. When we think of outliers in data, we think of this almost as a normal part of the data cleaning process, right? We have data, we see things that don't belong there, and we get rid of them, right? Now, this is very practical and has uses, but this is actually a really important case of this mind projection fallacy. See, we have this internal sense of what this model should look like right here. We believe that it should be a bunch of clustered things around a normal distribution, and we sort of project that onto the real world. And when we make this projection, we censor this data point because we say it doesn't belong, right? That's the logic of removing outliers. But the data is what's real out here, right? This is just our mental model. So like when the coronavirus hits, we might see some of those things as outliers, and we would be wildly incorrect to remove those from our data set because they're not really outliers. The world is changing. These are a sign that the world is not the same today as it was yesterday. So in practice, of course, it's okay to remove outliers. The message here is not when you go back to work, don't remove any outliers in your data, don't clean your data. But it is important when you do that to realize the relationship between your assumed model of how the world's working and the data that you're removing. If you're at least aware of this, then you can think maybe those outliers mean something. Maybe there's something important. So all of this is good, and we kind of have fleshed out the limits of probability in a positive sense, right? So we're in this space of probability. Probability is a statement about our beliefs, about our mind, and about the world, and the beliefs we have about the world. But this is something that's baked into this, is this very big assumption, right? We have this hypothesis, this data, and we kind of see this line here in this mathematical notation as being a real line that separates our mind and the world. We deeply believe that these are separate entities. And that's a core part of everything we've described so far, right? We're trying to balance our internal mind with the world. And this is where we start bumping up against the real limits of probability and the things we have to sort of think about in a philosophical sense. So it all really starts with the I, and the I is a recurring theme sort of this whole talk, is we'll sort of see how what we observe, how we perceive the world, all of those things get really complicated, and it makes the details about how we think about probability a bit more complex. So let's start talking about vision and talk about color in particular. When we think about color, we think about often this sort of scientific view of color we have from Newton, right? So we know from science class that light is of different colors. It hits an object, and then light is refracted back from those objects, and that's what color is, right? We see green light bouncing off a tree leaf, and it comes to our eye. And this is sort of the Newtonian view, and this is sort of the view we have of science, right? We have this very clear world that we observe, and the data comes in through our eyes, and we can make really solid judgments about that data. And that's how science works, come up with hypotheses about that. And this is great. But there's an interesting case where, and this is it, right? So this is our thing. So we have our head, right? We have our eye. We have this green tree. This is our data. Data lives out here. So this is all our Bayesian, or not Bayesian, our probabilistic thinking. And this is all fine and good. And this is how we kind of view normative science, right? Scientist looks at the world, sees a green tree, counts green trees, says how many green trees there are. Very straightforward, right? But a lot of actual thinkers in color theory, Goethe and Runge and Schopenhauer in particular, were thinking a lot about how color works. And I'm going to read you this quote from Schopenhauer. It's right here if you want to read it along with me. But I think it's a really interesting thing. And I'm going to explain it in detail as we go through. So Schopenhauer's theory of color says, because we think about color, right? We think about how we draw, how we do things. The color you learn in science class doesn't always seem to quite match up with the color that you see like on a palette or with a paintbrush, right? And there's reasons for this, right? Because there's something happening in the eye. So Schopenhauer writes, color is and remains stimulus to the eye. The object is merely being intuitively perceived as its cause. Color itself, however, is only the effect, the state produced in the eye, and as such is independent of the object, which exists only for understanding. For all intuitive perception is intellectual. And so let's see a bit more what Schopenhauer means here, right? So we think of this green tree as being the green thing out there. But what Schopenhauer is pointing out is that color is actually activity in the eye, right? The idea of saying a tree is green is this projection. Again, this is almost a reiteration of the mind projection fallacy, but in a way that kind of challenges the probabilistic parts of that, right? This is saying even this data is a hypothesis we have about a tree that we kind of stick out there. What's really happening is these reactions in the nerves in our eye. And this may sound again like, well, this is sounding a bit philosophical, Will. I don't really know if this is true, but I for example, am red-green colorblind. So for me, when I see a green tree out in space, I know it's green because people tell me it's green, right? So it actually is a observably social component to it, where I see a tree and I know it's green because I was told it was green. When I was in kindergarten, I used to make purple skies with brown grass because I didn't know how the crayons were different. So I've actually seen there's sort of this component to how we perceive the world and describe the world that depends a lot on a lot of stuff happening in here. And now we're in this interesting place because vision is just a small part of this, right? I mean, this gets to the larger question of hallucinations. This comes up a lot in horror. I wish I had time to add a whole component about fiction and horror writing to this, because you think one of the key elements of horror, especially like H.P. Lovecraft, or a lot of other horror writers. Jeff Vandermeer's Annihilation is another great example, where our inability to perceive things correctly, the idea of hallucinations, the idea of seeing that which we cannot comprehend, really challenges our ability to understand the world. And so we get in this sort of bubble of our minds at this point. And this is another thing. So the next thing we're going to talk about is this bubble of our minds, right? So at least we're in our head, right? We kind of have our thoughts. We kind of feel that this border here is very strong and very real. And we have this problem with data and hypothesis, because data and hypothesis are now really good friends and they're kind of living close together. That green tree is not so much a scientific observation, but we're still in the head. So I want to talk about a really great French critical theorist, psychoanalyst technically. So he's a psychologist, but I think it's important to sort of think of Jacques Lacan as his name. And he's a psychoanalyst, but I think it's good to sort of think of him as a philosopher as well. I'm not proposing we interpret Lacan as a theory of the mind person, or that we operate psychology this way, but I think this is a useful tool for understanding knowledge. So Lacan is a French philosopher. And one of his most important writings is about this purloined letter essay by Edgar Allan Poe, a story. And if you've ever heard literature majors talk about signifier and signified, he's the guy who a lot of this comes from. And as a point of this, so signifier is the thing that represents another thing, and the signified is that thing itself, right? Now, normally, we think of like, that's the real thing, right? The thing that it means. Like a word is just a symbol, and the thing the word points to is the meaning. If I say cat, that's the word, it's a symbol, and this is a cat, right? That's the real thing. But Lacan is actually really interested in how important just the symbols are. So he describes this story, an Edgar Allan Poe story, where a letter is stolen. And it's a letter of political importance. And it's a whole story. This letter is incredibly vital to everything. All the drama, all the tension comes through this letter in this story. But we never know what's inside the letter. And Lacan points out that actually doesn't matter at all, right? This letter as a symbol and what it represents and how we manipulate that symbol has a lot more to do with how reality works and what that symbol actually means. So if you ever hear people babbling about signifiers and signified, that's actually what's being talked about. And it's actually an important thing. So it's the primacy of the signifier, right? The thing that represents. So Lacan has this really great part of his analysis that talks about the mirror phase. And I think this is a really important thing just to think about what it means for this eye that we've been studying to look at itself in the mirror, right? So this is a really interesting moment in observation, because we have this hypothesis space, and then this is the data for the hypothesis space. We're sort of reasoning about ourselves, and this is a really interesting time to sort of look at the limits of probability again and say, like, what happens when we look in this mirror? What do we see, right? And what we see is a whole bunch of symbols, right? We have these things that help form our identity. I deliberately chose emojis here because these are literally symbols, right? We use these symbols all the time and they mean different things. And when we look in the mirror, we see things like gender or sexuality, and we see nationality, we see ethnicity, we see our interests, our knowledge, our background. And we sort of form this picture of who we are, right? And this is also a symbol. I deliberately chose this one. This one makes me laugh. It's literally called man technologist, right? And it's obviously this very reductive thing, but I think at a technology conference, at this meeting, we often find ourselves, I am a mathematician, or I'm an academic, or I'm a management person. Like, we have these emojis we associate with ourselves. But let's think about this in sort of this probabilistic sense, right? We think about this as the data, and this is a hypothesis, but this seems very complicated, right? These aren't really data, right? Like, we know gender and sexuality are definitely tricky things to sort of indicate as a simple binary value, right? And nationality, you could say nationality, Will, is the place you were born, but being born on a geographical point, that may be a fact, right? But being American is certainly a distinct thing from that. And we could try as we might. Same with ethnic, right? You could say, well, your skin is awfully pale, Will, but that's not the same thing as what whiteness means and all of these other things, right? These things that are our data that help build this model. And these are in many ways symbols, right? We could try to define them, but it's symbols that we use and we see, and this becomes our data, but it's not data in the way it was in a probability space, right? In this probabilistic model, this input is very different. And same with this hypothesis, right? This man technologist, if I am to define myself based on the things I see, I say I'm a man technologist, right? That's not a hypothesis in the same sense, right? This is also a symbol, and these are symbols. So Lacan breaks this down in an interesting way. And he has this diagram, and he has all kinds of fascinating diagrams. He's a really interesting thinker and somewhat complicated reader, but he breaks this down into these different components. And I'm going to show these really quick, but this is the subject. This is the small other, the big other, and the ego. You may be familiar with these terms from psychology, but we'll break them down a little bit more in terms of what we already saw. So the subject is really this I that is perceiving the world, right? This is the thing that sees, right? This is different than the ego. This is different than the who I am. This other, in the case of looking in the mirror, is the person you see there, right? But I am also the other if you see me on the street, right? You can look at me and I'm another person. Other groups of people can be that. And the ego is this sense of who we are, this sort of person that we create, right? This big other we'll get to in a bit. But you see, this is sort of where all these symbols come from. So I want to take a moment to look at this very crazy sort of chart, right, we have here. So we have this, the eye sort of sees this person here, right? So we see this other, we see this person in the mirror, and we have this relationship with that person based on this sense of this ego we create. But where does all this come from, right? So this is where this big other comes from. And what do you mean big other, right? What a sort of absurd sounding concept. But when you think about it, there is this other person, right? When you talk about like an American, you know how Americans are, right? Oh, who is that you, right? Who is that person that knows that? When we talk about gender norms, right? Like what it is to be a man or a woman, or what else we can do with that, right? Who defines that, right? There's always this sort of audience we're thinking about. There's always this other person that seems to know what these symbols mean, that all these symbols sort of come from. You could think of it as culture, but I think culture sort of underplays the complexity of what's going on here. And so this big other, right? This big world of symbols and representation defines what we see, right? You notice that the arrow is not from subject to the ego, right? In Lacan's view, the arrow is from the big other to this, right? So this too, this symbol of this man technologist, where does this come from, right? This is part of the world we live in, this larger consciousness that there is, right? This more complex world of symbols and language, and this is a very tricky thing, but this is sort of the basic structure. So we can see that this big other kind of influences this I that we see, and then we have this other people we see, right? And we imagine that in relation to this person we create, which is created by this society at large. So the big thing to take away from here is we're far out of this simple head model, right? We're not just in this head space, right? This head space is part of this symbol space, right? And you can say that this is language, this is culture, this is many things, but this metaphor of the big other is a very useful tool. And this is important because it plays a role, and we'll talk about that next, about how this influences the way we perceive things. It actually affects how we think about hypotheses and about data. So this is, like I said, I want to move beyond just the big other being this idea of culture, which can be a really quick way to write this off. The big other is this actual real presence in the way we interact with the world. And I think you'll see that more as we talk about different examples. So the classic example of this is actually the emperor's new clothes. Now, I think this is a pretty multicultural story. People have heard of this in different places, but I'll retell this just in case. So the story is there's an emperor, and this is a very friendly drawing. He's not totally nude, but the story is there's an emperor that has two con men who approach him, who claim to be weavers and tailors, and they say, "We will make you the finest clothes in the world, but there's a catch. This thread is so exquisite, so amazing that idiots and people that are too full of themselves, they can't see it, right? So only really sophisticated, sharp people will see this clothing." So of course the emperor goes out, and then a young child has the boldness to proclaim he's got no clothes on, and everyone's shocked. And, you know, we hear this story so much, we almost forget that it's interesting. You probably are thinking, why does this even matter, right? But it is interesting because it's not just that this kid is bold, right? There's something else strange going on here. Literally everyone else in this picture knows this, right? What this child is saying is not new information. It's not an interesting fact, right? This is not adding information to the picture. Who is it that doesn't know this, right? Literally every person here, if you could go inside that little map of their head, they're fully aware that this is happening. And this boy saying it from an information standpoint, as technologists, right, thinking about information theory, this boy is not adding any information to this set, but it's shocking, right? This is a shocking revelation. And it's because this big other, right, this sort of collective sense of who these people are, this sort of system of symbols and signs and all that, that person, that imagined other, is not aware. So when this boy says this is this sort of shocking thing. And I really like thinking about this in a probabilistic sense, right? This is our data, right? Everyone sees the same data. It's a shared data. The emperor has no clothes. We all come to the same hypothesis, right? The emperor has no clothes. And the boy shouts H, but somehow this collective other, our society at large, the larger system we belong to, sees this and proclaims that it's not true, right? Now, this is an extreme probability of the hypothesis given the data is 1 versus 0, but we can imagine softer versions of this. And I think we've all seen situations like this in real life, right? I think you've probably been to an office meeting or people have talked about things and you feel like, aren't we forgetting some obvious fact? Or you've been part of some university ceremony and you're saying, isn't something here ridiculous? I wish someone would say it. I think we can all think of cases where there's been this weird thing where everybody knows that something isn't quite right, but we can't really say it, or we don't say it as strongly as we all internally believe it. So this is where we can clearly see probability has completely broken down. And of course, I want to bring up the most pressing example of this right now is obviously climate change, right? So this is a journal article from 1896 about the influence of carbonic acid in the air upon the temperature of the ground. This guy won a Nobel Prize in chemistry, so this isn't just some random author. And so people were aware a long time ago that there may be this hypothesis, this concern about the way CO2 affects our environment and our atmosphere and the Earth. So this isn't some new shocking idea, it's something we've been thinking about for a while. And we have the data, right? We know this. We know CO2 is going way up. This isn't a shocking thing to anyone here. Again, this is sort of universally shared data. We know it's getting hotter, right? This is this May. It's a pretty dramatic increase in temperatures. We see that the Earth is heating up. And in the end, now we're back into real data here, right? This isn't just philosophy anymore. This is actual looking at numbers, asking questions about the world. This is the Arctic sea ice. This is my favorite diagram of where we're at. If you haven't seen this, it's really fascinating. These axes are a little bit hard to read. This is 2020, but what you can see is you have each month of the year, and this is the volume of sea ice. So we see as time goes forward, the maximum and the minimum. We're not at the minimum yet for this year, but you can see the minimum now is about the same as it used to be 30 years, like 40 years ago. And we can see that the Arctic is going to disappear. We'll have a blue ocean Arctic at some point, which should be shocking. But it's also something we all know. I don't think there's that many people in this room who this is wildly new information to, but we don't act like it, right? We don't really talk about this. We say it's bad. We say I'm concerned, but we're part of this larger system. It doesn't really let us talk about the reality of this. We know carbon emissions aren't good. We know that the climate is in a lot of trouble. And we have this, but we have this economy we have to grow, right? We have these things we have to do. We all work in tech. We all are very familiar with venture capital, with generating revenue, all these things, right? These are part of our world. And this is not, let's be clear, I'm not trying to make some moral speech here about, we should recycle more, or we should do this more, or we have to stop doing things. I want to point out that these things influence our thinking about the world, and so we can't actually even have these conversations because we're not questioning that big other, right? That sort of limits how we can talk about these things. And it's complicated because it's not just that we know climate is happening, right? The fact that climate change is happening is not a shocking emperor's new clothes thing. What's a harder thing to say is what's going on that leads to this, right? So here's personal consumption in the United States during the pandemic. I think this is something that's also, again, this is US specific, but I think this is something we've seen across the board in different countries. We've had a decline in consumer spending, right? People buy less, people have been out of jobs, all these things, right? But this also has a very strong relationship. This is a great article in the New York Times. I recommend checking it out if you get a chance. But we have this is carbon emissions. This is actually what we want, right? We want this to go down, right? This is our goal, right? if we want to stop the Arctic from melting, if we want to change the course of this, we have to actually get carbon emissions down. And we did in April, and now they're back up, right? So this is important though, because this is actually the goal state we're in, but we can't stay here, right? People are eager to have a V-shaped recovery. We're eager to move forward and get business running again. And this is closer to that hypothesis from the data, right? We see this is true, right? We know that consumption, we know that in general, how things run is complicated, but again, it's a real issue. This isn't just like okay, now we have to stop consuming, because we know what also happened, right? We had, this is unemployment claims in the US. Again, something I think we see similar global patterns, not as bad as the US. I know we're particularly egregious in this case, but this affects people, right? This is not just, oh, big corporations, evil things. We're all caught up in this, right? This consumption, it also pays for our jobs, pays for our lifestyles, right? And this is all part of this. But the fact that we can't engage in this deeply and have sort of deep discussions about this is actually one of the bigger problems. And again, this is beyond just probability, right? You can't just use models to solve this. You can't just use technology to solve this. So to sort of start, to wrap up, to say, what's the point of this talk, Will? I think the thing is, I like I said, my goal isn't to get you to recycle more or to even say, I think I'm going to fly less or drive less or any of these things. It's even sort of more foundational of we all have this mental model in our head, right? We all have this male or female technologist of different colors, but we have this definition of self that's defined by this larger social structure we belong to. And my plea is just to question that, right? To look beyond sort of the technical tools you have. If you come to a conference with your laptop open, this is exactly what I look like right now. I don't have blonde hair, but like I'm here with my laptop. I'm the male technologist. But to really understand our world, to really start tackling larger problems, we have to start questioning, where does that come from? What does it mean to be a male technologist or a female technologist, or all of these different roles? What's defining me? What's my role in all of this? And to sort of break out of this sort of thinking in these terms of these models and of these tools that we have that are very useful. Probability is a great tool. I think we should use it every day. It helps us understand a lot of these things, but we also need more. So that's really the plea here, I think, is that for everyone to continue to sort of stretch out and define yourself in a larger sense and ask questions about where these symbols come from and how we work with them. So end with one more eyeball image. This is a famous quote from Theodore Adorno, and I really like this. So, I think a good question would be, how did we start? How do I start thinking about these things? What should I do? Should I read some books? Should I do this thing? And I like this quote because it captures, I think, the best way to start thinking these things. So he said, the splinter in your eye is the best magnifying glass. So, the idea here is that those things that trouble you, that frustrate you when you see things, and climate change isn't the only one, right? Climate change is just a very good universal example. In the United States, we have a lot of problems right now with racial inequality, mistreatment of minority groups, and those are another thing. So whatever that thing is, start with that splinter in your eye, start asking about that thing, but don't just rush to react as your man technologist, woman technologist, whatever that role is, manager, academic, however you define yourself. Question the larger structures you belong to that feed into that, and go beyond the limits of probability. Okay, thank you very much.
Okay, thank you very much, Will. I think this was a very challenging talk for everyone. There's so much I want to say. The first thing is that you cited the story about the naked king, and yeah. I'm reminded of a different example. Do you remember in Greek mythology, there was Cassandra, the girl who was cursed with telling the truth and nobody believed her? Sometimes I feel like data scientists, or I mean, everyone in general has this feeling. Sometimes they see something and just can't get the world to see it, even though the evidence is there. So I think for me, your talk was also about how to communicate and how to change the big other or the social constructs bit by bit. And I see like this world of meanings more like a battlefield where we constantly challenge things, and it's to me it's not like an awakening. Like you have to like really follow it, like you said, You've got to follow that splinter in your eye and challenge yourself and challenge others every day to get there, right? I don't know.
Yeah, no, I think that's fantastic. Yeah, I actually hadn't thought of the Cassandra story, but I think that's absolutely on point. I think that's something actually I'm glad you mentioned that, because when I actually wrote this presentation, I know it's a very sort of different technical talk. So even for me, I had this anxiety of like, oh my gosh, what if I give this? And the reaction is like, oh God, I don't want to hear, I just want to talk about math. Can we just talk about math, please? And so that's to say, but when you have that connection with others, right? And other people say, yes, I feel the same. I feel like there's something frustrating me. Yeah, it's just great to hear that. So, but yeah, and I agree. And I think that you're right. There's this part too, where we can kind of get isolated. We can sort of feel, there's a great writer I like named Mark Fisher, and he talks a lot about depression, and that we treat depression as an individual problem, but it's not. It's a symptom of a larger societal thing. And as long as we keep putting the blame for that on individuals, then we're going to continue to have problems. And it's a similar thing to what you're describing, right? If we don't say things, if we don't open up, if we keep in our sort of isolated places, it can feel very alone, and we can't even feel sane. Sometimes I just think, like, rather than like, how do you change the world? Like, how do you just feel more sane, right? How do you have a conversation where you say, okay, yeah, actually, I feel less alone now. Thank you. Thank you very much. That was great.
I'm a psychologist, so literally, I know what you're saying. I also think that mental illness is a social phenomenon. And on topic with psychology, Freud used to say that even though the psychologist might know what someone has repressed, even if you tell them, like, you're repressing this fact, they won't get there until they make all the connections. So I often also think about that, like, you can't just like slap the truth in somebody's face and get them to see it. You have to really get them there. I think teachers also know this.
Yeah, that's a great point. And also, I think it's also one thing I thought when putting this together is sometimes people like a really punchy conclusion. Like, so what do I do? Do I go out? But I think telling people the truth is always a troubling thing, right? When you come up with like, here's the one truth I want you to see, that's a really tough message, right? Because I think we see that happen throughout history, where someone goes, well, I've got the truth, now I'm going to tell you. And then it's easy to say, okay, yeah, I'll listen to that truth. It sounds easier than doing what I'm doing, but that's a very complicated thing. So in a way, you can't espouse a truth that other people don't find on their own. So yeah, that's great.
Yeah, I think we have to build the tools collectively to see the truth and to get there. I want to read a question by our audience. Santiago Gonzalez says, how do you think we as engineers or data analysts can overcome this big other and be able to evolve as a collective?
That's a great question. And I think, I mean, the big other is something to challenge, but it's always present, right? We always have this social thing, like whatever group we're in, we have this thing. So it's not just like a goal to like topple the big other, right? But it's to be aware of that. And so I think that actually I would say that is the as engineers part, right? Is a good part to start questioning, because I think we define ourselves as, and I do this too. This is why it's something I've been thinking about. So a little background, I was an English major undergraduate studying literature and philosophy, and then got into technology. And for many years, really fought to see myself as a technologist, as an engineer, as a data scientist. And so I think when we see ourselves in that realm, we sort of see ourselves as these, as this person with this limited toolbox. So I actually recommend seeing yourself as more than an engineer. On my blog, I wrote about Audre Lorde, who is this amazing Black woman feminist that said, the master's tools will not dismantle the master's house. And her theme was that, you know, at these academic conferences, they're limited in their ability to address issues of racial inequality and of even feminism. So there's this feminist conference in the 80s, and it's all, you know, academic feminists, very interested. But Audre Lorde's point was that within this framework, you're going to always be limited in what you can do. And I think it's particularly tricky with us as engineers. I work, you know, I work for a startup. I'm an engineer in many ways. And, you know, our livelihoods are tied up into this world. So I think that's why I think it's almost dismissive to say like, oh, just, you know, we have to do the right thing. I think I actually don't have a great answer other than to start thinking about being more than just this engineer, and think about also as an engineer, what are the things that benefit you from the way things are, right? Like I sell airline tickets, right? So I benefit from airline travel, obviously creates CO2, but that affects me. So I think it's, yeah, I think it's a tricky answer, but I think it starts with sort of saying, okay, like, what else? Like, let's not just be an engineer, right? There's lots of great tools and opportunities I think will come up with that as you do it, but let yourself get out of that zone.
Yeah, I think education has a really key role in that, and making like integral human beings, not just like tools. Another question from our audience says, would questioning our hypothesis and model only leave us with a different model, but still isolated from the world? Without a model, there would be no mind at all, would it?
That's a really good question. So I think that, and that's particularly why I am into sort of Bayesian probability. I believe we always only have a model of the world. And this could, of course, go deep into philosophy, right? There's plenty of philosophers that kind of go this direction. And I kind of fall that way, is that, this idea of this sort of like very real world out there is actually tricky, right? We kind of have this sense that everything is exactly it. It's our mind and the world, but we're always sort of defining the world by these models. And again, these models are part of the larger society as well, right? Not simple ones, but all of them feed into that. So I think, in the Bayesian framework and sort of a probabilistic mathematical framework, the approach I like is this idea that you're never really establishing one model, right? You're always looking at which model explains the world the best, and then you're kind of iterating on that view of a model. So to me, it's to not be fixed on a model, but to always be open to changing that model. And I've actually used that framework of sort of statistical thinking to help me understand and sort of develop in the world. When I see data that sort of contradicts my beliefs, you have to ask yourself, okay, well, maybe the beliefs have to go, and we have to keep sort of iterating on that. So yeah, I guess to sort of answer that, I think we're always sort of in this model thinking world. We always have models, and sometimes the most dangerous models are the ones we don't account for, right? In a very practical sense, I've had a lot of jobs where a team will not have a model, and they'll say, your model has errors. And I said, but you don't have a model. You're just like assuming something always happens, right? Like, you're not accounting for your errors in your model. So I think in a lot of ways, it's good to question what you think is not a model and what actually turns out to be.
Okay. I have a commentary, which is, I'm there for the talk about perception and horror films and literature. Just that.
Okay,
I
great.
don't know if there's another question from the audience. We will wait a few minutes to see if somebody else wants to ask something. And yeah, I wanted to add, like, for me, this was a really surprising talk. I knew it was going to be surprising when you shared like the slide about Lacan's thought. Here, my teammate Juan says there are lots of congratulations when you do. Like, I think people's minds are blown. Yeah, and so especially, I also come from a background of humanities, and I wasn't expecting this at all. So I think it's great for us to always like challenge our assumptions, and not just from a data science point of view, like from a human point of view, and always like be humble and non-attached, which is the most difficult thing to do.
Yeah.
Emmanuel says, the fact that I identified the real data in social scientists could be a reason of why mathematics fails in this. I'm not sure I understand the question.
Yeah, I mean, I think I'm not sure I totally understand the question, but I think this brings up this perpetual issue between social science and quantitative science. Being an English major in tech, you always feel this friction between these two worlds, and it's forever frustrated me, because when I was an English major and learning about math, I used to always try to get English majors to see that math is important. I think it's very easy to go too far one direction, and English majors just don't want to look at data. They didn't want to look at models, and I was like, hey, no, this is really useful. And then later, and you need to understand probability in math to understand the world, right? Like, you can be very easily tricked if you don't know how to understand probability. If you don't know how to look at the numbers and say, wait, that's not what's happening. Even with like coronavirus, right? It's useful, even if you don't have a great model, to just at least be able to estimate an exponential and say what would happen if this happened. And it's necessary. But mathematics has this limit, and I think it's a common misconception among very quantitative people that's true. So I think people sort of have this belief that mathematical reasoning, therefore, is the best reasoning, right? It solves these problems that English majors can't solve. But I think, and that's why I tried to show in this talk too, it's not just this two different views. There really is this limit between the two ways of thinking. And so you really need to be able to go through both. And yeah, so I think that's the tough thing is sort of quantifying when does mathematics, what are the limits of mathematics? One thing I always think about with science, like very sciencey people will always say, well, is this falsifiable? And I always think it's a funny thing to say, because Karl Popper is a famous philosopher who said, real science is what you can falsify, right? You have a falsifiable hypothesis. But one thing that I always like to point out is that you can't have that be your only way of thinking about the world, because that definition is not falsifiable, right? Karl Popper's definition of how science should be is not able to hold up to that standard. So in that one example, you can see your whole life can't be defined by saying, is this a falsifiable hypothesis or not? And if it's not falsifiable, I'm not talking about it. That may not be normative science. I think Karl Popper may have a place to describe what we consider normative science, but it certainly isn't the limit of how we think about things. So yeah, I hope that addresses that question.
Another question from Tobias Pucci says, this big other definition is quite interesting, but do you think that it being different from our ego is important and necessary? Because that would be, if data models could be, because what would we be if data models could define us as we define ourselves?
Yeah, that's a great. And so actually, I think it is definitely, it is separate from the ego, at least in a sense. One thing I wanted to point out I forgot, especially I think about Freud, is so like when you think about psychoanalysts, or think about psychology, you often think of like the unconscious, at least I did before, as sort of this inner thing, right? It's like this stuff inside your head rather than actually a shared medium. So I think the idea of the big other that I really find fascinating, which gets to that other point that the question was asking, was about this sort of data defining the hypothesis back and forward. I mean, it gets to practical things like model bias, right? But the idea that the unconscious is actually not this private thing; it's this shared thing, and what we think of, and we're trained in our society, especially like in the West, a lot of strong individualism, right? We have this huge sense of that, like I am me, that's important, and so we kind of underestimate how much we're actually connected to a larger sort of framework. But this, getting to the idea of the data and the hypothesis, right? If you look at work going on right now and sort of the bias implicit in neural networks and these big, AI systems, you'll have gender bias, you'll have racial bias. It sort of shows that this data and these hypotheses are, even in very practical data science terms, very intermixed. And it's very important that we understand how that works and pull that out. But yeah, the answer, I do think that separation is important. I think that that sort of sense of ego and individuals who we are, and we often underestimate how much that's defined by our society, by our culture, by our own values, and all these other complex things. I think we often own that more. And for me, that's sort of been, even more recently, this sort of big revelation of, oh, right, yeah, like we're part of this language, this whole world that's bigger than that.
Sure. One more question, and I think we have time for one more. We have time. So Leonardo says, Will, do you have any hint of how to characterize the difference between the models and hypotheses that a person can come up with and the ones a computer can make up, assuming there is a difference at all?
Oh, that's a good question. I mean, I think that's a really good question. Because I don't know if I have a great answer to that. I mean, I think in some way they have to be the same, right? I sort of think it's like a deep like neuroscience question, right? Like what can a computer do? What can a human do? What hypotheses belong to one or the other? I don't know if I have a good answer to that. I think I'd have to give that some more time, some more study, but I think it's a great question.
Okay, maybe for the next BuzzConf talk.
Yeah.
Another question from Santiago says, great talk, really. I think while studying, you're not always taught to see the whole picture and to allow yourself to come up with innovative solutions to your problem. Thanks. So it's not really a question, but it's.
I'm glad to hear that, though. Yeah, I think that's an important. I think it's an important thing. I think we've really been. We're sort of trained to find our world and live in that and not question it. And even in the broader sense, I would say, even if you look at my whole talk, right, there's a lot of white male Western philosophers in there. So one critique I was actually hoping for, that someone would call me out on that and say, well, look, Will, you're still in this framework. And I think that's actually very true. I think there's another philosopher, Althusser, who talks about how even philosophy itself, right, is within this larger framework. We see it emerge in cultures with certain hierarchies, certain systems. So it's sort of never-ending process of asking those questions.
Yeah. Is there another question from the audience? I love to see this amount of participation. I think people are.
Yeah, I'm so happy that people have so many comments.
So we have more people in YouTube for now. So these are all the questions they could come up with. I think you left us all with a lot to think. And I think it's great because what we seek here is to connect people with talks that they can bring to their daily practice and elevate it a bit. We are not looking for like purely technical, I don't know, tutorials, but with things that will really leave you with something more substantial. And this is a great reminder that the things we are seeing now in the world should leave us not with shock only, but also with some kind of doubt that maybe the world we have been living in for a lot of years is not like the default, is not like natural, normal. I think we now speak a lot of the new normal as if we had lived in a kind of normality before, and maybe nothing is normal, you know. Maybe
yeah, I think that's a great point. Yeah.
Maybe we should be always questioning what is.
You should always question normal, and always question who does normal benefit and who wants you to think that that's normal, and how does that all work? Yeah, like what is normal is a very good place to start questioning things.
Yeah, I mean, this kind of discourse in our country, specifically in Argentina, we have a lot of poverty, and people are like calling this the old normal. And I think it's good that not everything normal stays the same. So I'm a bit excited to see like what kind of creative solutions we can come up with. And these periods of uncertainty always bring some of the best qualities together with some of the worst, but we have to push for the best. And I think questioning our privileges and you know, like trying to see things through other lenses can be one of the keys, together with, you know, strong statistical inference.
Well, thank you so much. This was really great. I had a great time presenting, and I'm so glad that
me too. And I see that everyone else too. So thank you very much, Will. It was a blast. And please, if you ever give that talk on terror fiction, just
I really want to put that together. Yeah, I'll have to do more of that.
Okay, bye.
Awesome. Thank you.
See you soon.